Okay guys, introduce myself. My name is Richie HAKIM. You can call me Richie and my number is 24055531022 from University of Udayana, Fakultas of Engineering. Now I present of friction force. And next, first one, background friction force. What is a friction is force the force that occurs when two surfaces come into contact and resist movement. This force is existence because it allows human to walk, fish to move and stop, and machine to operate smoothly too. The magnitude of the friction force is influenced by the type of surface and the normal force acting on the project. Understanding friction is the basis for designing mechanical systems that are efficient, safe, and have minimal wears. And this one, normal phase and right moving force and left friction force. Next, working principle of Wheatstone bricks. Static friction force expression V F equals static friction force and to kinetic friction force. V equals kinetic friction force. And next, tools for friction force experiment. 1. Test area or wood. 2. Test blocks or test object and wooden or metal blocks. 3. Dynamometer or spring scale or tensile force meter. 4. Ballots or weights to increase the normal force. And 5. Scales or measuring the mass of the blocks. 7. Meter or rules measuring distance moved. 8. Pull rope optional to pull object more stably. 9. Force sensor modern experiment version. 10. Stopwatch optional if you need sliding time. 11. Additional surface plastic. And that's tools for friction force experiment. Next slides. Experimental producer. And 1. Scale the wooden blocks mass with the digital scale. 2. Put the block on the table that have been prepared. 3. To measure static friction, pull the block slowly with the spring balance till the block vertically moves. Then take note of the maximum pull force. 4. Take the data and calculate the static coefficient with the equation that has been provided. And 5. Make a graph between the pull force and the force friction. And 6. Scale the wooden blocks with the digital scale. 7. Put the block on the table that has been prepared. 8. To measure kinetic friction, pull the blocks with a constant speed and use the spring balance to find the pull force. 9. Take the data and calculate and kinetic coefficient with the equation that has been provided. 10. Make a graph between the pull force and the force friction. Next slide. 1. Experiments produces our scaling for static force coefficient. Scale the wooden blocks mass with the digital scale. Put the block on the table that has been prepared. 3. To measure static friction, pull the block slowly with the spring balance till the blocks presently move. Then take note the maximum pull force. 4. Take the data, calculate the static coefficient with the equation that has been provided. 5. a graph between the force and the friction, and to experiment prove the scaling for kinetic force coefficient. Number 1. Scale the wooden blocks mesh with the digital scale. Put the blocks on the table that has been prepared. 3. To measure kinetic friction, pull the block with a constant speed and use spring balance to find the full force. Take in the data, calculates the kinetic coefficient with the equation that has been provided. 5. Make a graph between the pull force and rest friction. Next slide. Number 1. Experiment data calculation. This would, or this you look in coefficient, and this number 1 is 0.7, and block works coefficient and statistics. Next slide, and same experiment data to correlation. This slide you look words and coefficient kinetics 0.5 and 1.1 and 0.6, and you look coefficient and kinetics and 1.1, and wood and elasticity 1, and elasticity wood is 0.8. Next, static force graph. You look static graph in 1.0 from 2.5. Okay, next. And summary, you look like on the objects move at steady velocity, the measured force stabilizes this adhesions that kinetic friction do not depend strongly on speed. And 2, you look, that's my picture, and 2, the functional force is premised to be proportional the coefficient or friction. This coefficient of friction are questions or a given pair of surface. Okay, that's Okay, next slide. Okay guys, thank you very much. You look my presentation, and thank you very much. Okay, next video. Okay, thank you. Bye bye.